Let's look at this exercise 5, which I mean is exercise 4 here. Okay, so this exercise asks in this ring polynomial, the Jacobson radical equal to the Nilradical. Nilradical equals Jacobson radical, which is the intersection of the prime ideal equal the intersection of maximal ideal. So, the interesting thing is that we just describing the exercise for that. There is a characterization of this. Characterization of the Jacobson radical would be 1 plus xy is in A for whatever y is in A. If you want to show this is the same, because in general we know this is always the case. If you want to show this is the case, you can use this equivalent description here. It's our exercise 4. So the proof would be show that X is contained in Nilradical if and only if, I mean, okay, we don't have to do this, so I just put it more simple. We just want to show that X is in, this is what the question. Intersection M implies that X is in the Nilradical, but this implies this is equivalent to 1 plus xy is in A. I'm sorry, so here what I mean, of course, what I mean is this. What I mean is this equals, this is units of AX. And so what we have to do is just use this equivalent description, and for any y right, the question is, can you use this to prove X is in the intersection of the prime ideals? This is Nilradical. Maybe we can use slightly from our exercise before. Nilpotent for F is equivalent to, let me call this F. Yeah, our situation. F is nilpotent if and only if all the coefficients are nilpotent. That's what we have proved. So now the question would be this: if n plus fg, of course this is a possible method, this is not necessary, but it's sufficient. It's sufficient to prove this. If you know your f satisfies 1 plus fg is unit. Can you show that all the coefficients of your f will be nilpotent? So firstly, just do computation. 1 plus fg is already in, let me just call this b, is a unit. This implies that by exercise 2, 1 plus degree 0 of f degree 0 of g is in unit of a, and then can you show this, that this implies C0 is nilpotent? Direct computation seems not very obvious, but this also implies all those degree 1 terms are nilpotent. In our case, actually, if I want to use this method, I will simply choose G to be identity and to simplify the situation. The question would just, to avoid making things too complicated, it suffices to just to prove this. It suffices to just prove I mean, this is the condition we have, just prove the AI are nilpotent. Then we just need sorry, it implies 1 plus C0 is in a unit, and then I'll say 1 C and Nilradical of A. But can this imply C0 is in the nilpotent of A? Actually, it cannot. It cannot. It can only tell it is in the Jacobson radical of A. Alright. But if we do some small trick, I'm calling method 2 if you want, or just following method A. This tells you that 1 is in a star and all the coefficients is in the nilpotent of A. This is exactly what we want. And this implies F is nilpotent, which means in the Nilradical. So we have proved, take an element from Jacobson radical, we finally proved it is also in the nilpotent. It is also nilpotent, so this finished the proof.